Probability Stats Lesson 1, Permutations and Combinations. The fundamental counting principle says if a task consists of a sequence of choices in which there are P selections for the first choice, Q selections for the second choice, R selections for the third choice, and so on, then the task of making these selections can be done in P times Q times R times so on and so forth number of ways. So if you have a sequence of choices to do something, then the total number of possibilities is how many possibilities there are for each of those choices multiplied by each other. Permutations is a selection of a group of objects in which order is important. When we say order is important, we mean that a group ABC is distinct and different from a group ACB or CAB, so order matters. If you're choosing distinct objects with repetition, so you can choose the same object multiple times, if you have n total objects and you're choosing r of them, then the number of possible outcomes is n to the r power. If you cannot have repetition, then that means that you can't repeat whatever r objects you're selecting. Combinations is a selection of objects in which order is not important, so the group ABC would not be distinct from the group BCA. A reminder from previous chapters, factorial is that exclamation point notation, and it means that you're going to multiply whatever integer is shown times every integer all the way down to 1. Your calculator has a factorial button. If you go to math, go over to probability, number 4 is factorial. The fixed price dinner at Mbeka restaurant provides the following choices. For appetizer, you have super salad. For an entree, you have baked chicken, broiled beef patty, beef liver, or roast beef au jus. And for dessert, you have ice cream or cheesecake. How many different meals can be ordered? So for appetizers, there are 2 choices. For entrees, there are 4 choices. And for desserts, there are 2 choices. So this is the fundamental principle of counting. So there are 2 times 4 times 2 options. So there are 16 possible meals. The International Airline Transportation Association assigns a 3-letter code to represent airport locations. For example, John Wayne Airport is SNA. Or the airport code for Fort Lauderdale, Florida is FLL. So notice that repetition is allowed in forming this code. How many airport codes are possible, assuming all combinations can be used? So this is a permutation that allows repetition because different order matters. A, Z, C is different than C, Z, A, or whatever. So we're going to use the formula n to the r power, where n is the total number of objects, and in this case the letters in the alphabet, which is 26. And then r is how many you're choosing. So we're choosing 3 of them out of the 26 to make any one code. So we have 17,576 codes, assuming all are allowed. So previously we were talking about permutations where we were allowed repetition, so that FLL is allowed. Now we're going to talk about permutations where you're not allowed to have repetition, so you can't have the same letter or whatever multiple times. The way we calculate that is NPR, where n is the total number of objects you have to choose from, and r is how many you are choosing. And you calculate it by n factorial divided by n minus r factorial. Or your calculator has an NPR button, math probability number 2, NPR. Newer calculators, you do that first and then you type in the 2 numbers. Older calculators, you have to type in the n first, then do NPR, and then type in the r. So suppose that a 3-letter code is to be formed using any of the 26 uppercase letters of the alphabet, but no letter is to be used more than once. How many different 3-letter codes are there to be? So similar to the previous question, but now there's this stipulation that you can't repeat. So whether you use the n factorial over the n minus r factorial, so 26 total objects factorial, divided by 26 minus 3, because we're choosing 3 factorial, or you use the NPR button on your calculator, you should end up with 15,600 codes. So there's about 2,000-ish less codes if you can't repeat the letters. The key piece of permutations is that order does matter. So again, the code ABC would be distinct from the code BCA. Whereas combinations, order doesn't matter. So for example, if you're picking a group of 3 people, it doesn't matter if it's Timmy, John, and then Sally, or if it's Sally, John, and then Timmy. That's the same group. That would be a combination. So the way that we calculate a combination is NCR, where N, again, is the total number of objects you have to choose from, and R is how many you're choosing. It is n factorial divided by r factorial times n minus r factorial. We have seen this before. When we were doing binomial theorem, we were doing n choose r. Our calculator also has an NCR button. It's math probability number 3, NCR. So how many different committees of 3 people can be formed from a pool of 7 people? So we have 7 people to choose from, and we're choosing 3. Order doesn't matter. So whether you use the full formula or you use the NCR button on the calculator, you have 7 objects, you're choosing 3 of them, so 7 choose 3, and you have 35 committees. So for this last one, how many different ways can you create a committee consisting of 2 faculty members and 3 students if you have a total of 6 faculty members and 10 students eligible to serve? So go ahead and pause the video and try this one. So this one has 2 pieces. It's partly a combination because you are picking 2 faculty members out of 6 possibilities and 3 students out of 10 possibilities. And each of those are combinations because the order that you pick them doesn't matter. And then it's also a counting principle. So I have faculty members I have to choose and students I have to choose. So for my totals, I'm going to multiply those together. So for the faculty, I have 6 choose 2, and for the students, I have 10 choose 3. So I end up with 15 possible committees of faculty, 120 possible committees of students. So if I multiply those together, I end up with 1,800 total possible committees. So the 3 pieces of information today are the fundamental counting principle. So if you have a series of choices, you are going to multiply the possible outcomes of each of those choices together. For permutation, order matters. So if ABC is a different group than CBA, that is a permutation, and there can be with repetition, N to the R, or without repetition, NPR. And then combinations, order doesn't matter, so any group of 3 is the same regardless of the order that they're in, that is NCR.